Okay, welcome to this lesson on applications of differentiation. What we're trying to do here is to try to apply differentiation in certain questions, and what's the use of differentiation, besides just using all the techniques. So one way is actually in coordinate geom. We're going to find gradients of certain curves here and there, and write equations of normals, right? So maybe just some recap. Usually, if you want to find a gradient of tangent, you can also easily find the gradient of the normal just by using number one, gradient of tangent times gradient of normal. It's equals to -1. Okay, so that's one key concept. The second key concept over here would then be to find the equation of a line. So a very standard one would be y minus y1 equals to m times x minus x1. Right, these are things that we can use to actually figure out. So the differentiation helps us because it easily helps us find the gradient. So in this question, I have a point P and it lies on this curve, and I want to find the gradient of the curve at P. So very simply, if I want to find the gradient at P, all I need to do is actually differentiate the curve first. So if I differentiate the curve, okay, the curve over here would then be dy dx. It's equals to 2x minus 6, right? How do we find the exact gradient of the curve at P? So we take the x coordinate, which is x equals to 4, and dy dx equals to 2 times 4 minus 6, and this is 2. So therefore, gradient at P is 2. Okay, from here we can find the equation of normal. So the first step would be gradient of normal will simply be -1 divided by the gradient of the tangent, which is 2, which gives us -half. Now the equation of the normal at this point also passes through point P. So we want to find the equation of the normal. The equation of the normal would then be y minus y1. y1 is the y coordinate of point P, which is 7, equals to -half of x minus 4. Okay, so you just need to simplify this guy over here. Okay, and you will get your answer. Y equals to -half x plus 9. So that's how you actually figure out the equation of normal. Now, how do we then find the coordinates of the point where the normal cuts the curve again? So this is actually simultaneous equations. Why? Because we have the equation y equals to x squared minus 6x plus 15. Okay, so pictorially, it actually looks something like that lah. Okay, assuming this is the curve. Okay, and let's say this is the normal. Assuming this is the normal, right? We want to find the point where it cuts the curve a second time here. So the only way is actually through simultaneous equation with the equation of the normal. Okay, so using simultaneous equations, this is my equation 1 and equation 2. I can equate them together. I do have x squared minus 6x plus 15 is equals to -half x plus 9. And from here, you do your calculations. You're gonna get a very interesting answer. You're gonna get x squared minus 5.5x, so that's minus 11 over 2x. Minus 9, that's plus 6 is equals to 0. And from here, I'm just going to multiply 2 throughout because it's easier. So I have 2x squared minus 11x plus 6 equals to 0. Okay, from here, I want to solve it, which is factorization. If I'm not wrong, I think my factorization should be correct. It will be 2x plus 1 times x minus 6, which gives you this. Let me think. Yeah, correct. Okay, so we have two answers. X equals to -half or x equals to 6. So the other coordinates is not, would be, oh, I think I kind of make some mistake. Give me a while. Oh, sorry. I make a mistake. Okay, I'm gonna make a mistake. I make a mistake here. I'm going to. Okay, so what we're gonna do here? Multiply 2 throughout. 2x squared minus 11x. This is plus 12, which equals to 0. We're gonna kind of factorize this guy. My factorization may not be the best at the moment, but let me think. We're trying to get negative 11x, right? Honestly, if you even if we know that one of our answers must be 4, so is yeah. I think I roughly know my answer. 2x minus 3 and x minus 4 equals to 0. And we have x equals to 3 over 2 or x equals to 4. So the other coordinates is actually when x is equals to 3 over 2. So when x equals to 3 over 2, okay, y is, you simply just sub it back into the equation. You can use any one, you can even use the normal one. So I'm going to use the normal curve because it's a lot easier to use it. Okay, and we will have negative 3 over 4 plus 9, which lands me with 8 and 1/4, which is 8.25. So therefore, the coordinates are 3 over 2, which is actually 1.5, comma 8.25. Okay? So yes, that is how you do part 2. Now this is a very long question, especially the third one. Okay? The tangent at another point Q lies on the same curve, which lies on the same curve, is perpendicular to the tangent at P. So the interesting part about this is when you have lines that are parallel, we can make the conclusion here, which is the third and most important thing that we learn in coordinate geom, is that parallel lines have same gradient. Okay, why am I using these? Because it's talking about perpendicular, right? The tangent at Q is perpendicular to the tangent at P. So this means that the tangent at Q is parallel to the normal at P. So how does this really look like? I'm just going to quickly draw this here, assuming that this is the equation. Okay, and assuming here that this is P. Okay, this is the tangent. Just roughly draw a tangent. Hopefully it looks like a tangent. Okay, the blue line is the tangent at P. Okay, I'm going to use a green line to draw the normal. So assuming this is the normal. Okay, this means that I have a point P somewhere that I'm going to duplicate this, that actually has the same, point Q somewhere that is actually perpendicular. So I'm going to use a different color for this guy. I'm going to use this. No, let's use what other colors do we have left? I'm not going to use red. I'm stuck. Okay, I'll use pink. Okay, so the pink color is actually the gradient of Q. The tangent of Q, and that means we have a point Q over here, and that's how it looks like. So understanding that since the gradient of Q, okay, for part 3, the gradient at Q is equals to the gradient of the normal at P, right? And actually, we want to find the x coordinate, right? The gradient at Q is still dy dx, right? So can I say the gradient at Q is still dy dx, which we found earlier? Isn't it just 2x minus 6 must be equals to the gradient of the normal, which we found? It's negative half. And hence, to find this is very simple. It will be negative half plus 6, 5.5. And so x is equals to 5 over 4. Okay? And so that's actually what we do to make sense of using differentiation to make sense of coordinate geom. Okay? So that's all for this part. See ya.